Good morning. In today's class, we will learn solving sum of subsets problem using backtracking. We have to find a subset of a given set A whose elements are A1, A2, etc. An of n positive integers whose sum is equal to a given positive integer D. That is, given a set, we have to construct a subset whose sum will be equal to the given integer D. Now they have given an example here. A set is given. A set is A with elements 1, 2, 5, 6 and 8 and D is equal to 9. We have to choose the element from this set such that the sum will be equal to 9. Now there are two solutions here. If you look at 1, 2 and 6, that is 1 plus 2 plus 6 will give us the solution 9 and 1 comma 8 will give us the solution 9. In this way we have to find the sum of subsets. Some instance of this problem may have no solutions. It is convenient to sort the set's element in increasing order, so we will assume that A1 less than A2 less than An. Now we can solve this problem by using state space tree. That is, constructing a tree of choices being made is called the state space tree. Its root represents an initial state before the search for a solution begins. The nodes of the first level in the tree represents the choices made for the first component of a solution. The nodes of the second level represents the choices for the second component and so on. A node in a state space tree is said to be promising if it corresponds to a partially constructed solution that may still lead to a complete solution. Otherwise, it is called non-promising. Leaves represent either non-promising dead ends or complete solutions found by the algorithm. In majority of cases, a state space tree for backtracking algorithm is constructed in a manner of depth first search. Now we'll see here. This is a depth first search or the state space tree which is constructed for a set of elements. Now we will see how this state space tree is constructed. The state space tree can be constructed as a binary tree as shown in the diagram. For instance, A is equal to 3, 5, 6, 7. That is, a set is given with elements 3, 5, 6 and 7, and we have to find the sum of subsets. That is, we have to find the elements from the given set whose sum will be equal to 15. The root of the tree represents the starting point with no decisions about the given elements made as it. Its left and right children represent respectively inclusion and exclusion of A1 in a set being sought. Similarly, going to the left from a node of the first level corresponds to inclusion of A2, while going to the right corresponds to exclusion and so on. Thus, a path from the root to a node on the ith level of the tree indicates which of the first ith number have been included in the subsets represented by that node. We record the value of S, the sum of these numbers in the node. If S is equal to D, we have a solution to the problem. We can either report this result and stop, or if all the solutions need to be found, continue by backtracking to the node's parent. If S is not equal to D, we can determine the node as non-promising if either of the following two inequalities hold. That is, s plus ai plus 1 greater than d, the sum is too large. S plus aj less than d, the sum is too small. Now we will see here. The given set is A with elements 3, 5, 6, 7, and we have to choose the subset of elements from the given set such that their sum will be equal to D. D, that is 15. Here D is equal to 15. Now in this tree, state space tree, you can look at, first I have written the root node as 0 because we have not made any decisions yet. Then the left subtree indicates inclusion of the first element, that is A1, and right subtree indicates exclusion of A1. So we will begin here. Here the first element is 3 with 3, and right side indicates without 3. Now I will continue with the left subtree, then we will move on to the right subtree. Then first, as I told you initially, the node is 0, we have not made any decision. Then the first element 3 with 3 left side, inclusion of 3, then we see 0 plus 3, that is 3 is the answer, so node is made as 3. Then the next element is 5, so we have included, left subtree indicates inclusion, hence with 5, 3 plus 5 is 8. 8 is included as the node here. Then the next element is 6. With 6, the sum will be 8 plus 6, 14. Then the next element is 7. 14 plus 7 is 21, which is greater than 15, which leads to a dead end. So now we move back to the previous step, that is with 8. Then right side indicates without 6. So left side indicated with 6 and right side is indicating without 6. Then 8 plus next element is 7. 8 plus 7 is 15, which leads to a solution. So we can continue doing with the next elements also. Then 8 plus 7, that is left side, is inclusion, and 8 without 7 is right side. So without 7 it remains 8 itself. 8 less than 15, so it leads to a dead end. Again we move back to the previous node, that is 3. So left side indicated with 5, then right side indicates without 5. So without 5 the answer remains 3 itself, the node is 3 itself. Then the next element is 6. 3 plus 6 is 9. Then the next element is 7. 9 plus 7 is greater, that is 16, which is greater than 15. Again it leads to a dead end. We move back to 3. Now next, with we saw with the 6, now right side indicates without 6, exclusion of 6. Then 3 with 3, that is there are no elements. 3 plus 3, it was remains 3 itself as the node. Then 3 plus next element is 7. 3 plus 7 is 10, which is less than 15. So it also leads to a dead solution. Then we move back to the previous node, that is 0. So with 0, that is 0 with 3 we started, that is left side. Now we move on to the right side without 3. In the same way the process continues, that is here without 3 there is no element, that is 0 itself. Then the next element is 5. So 0 plus 5 is 5, which is represented as a node here. Then the next element is 6. The left side indicates inclusion. 5 plus 6 is 11. 11 plus 7, next element is 7. 11 plus 7 is greater than 15. 16 is greater than 15. Hence this also leads to a dead end. Then we move back to the previous node, that is 5. Then left side indicated with inclusion 6. Now right side indicates exclusion of 6. 5 remains as it is. 5 plus 7 is 12, which is less than 15. So this also leads to a dead solution. Then we move back to the previous node, that is 0. That is 0. Now we saw right side with 5. Now we will see without 5 here. 0 plus 5. 0 without 5 is 0 itself. So this leads, we have completed all the possibilities here. So the only solution, the solution we will get is 0 with 3, then with 5, then without 6, and the solution will give. So that the elements of this subsets are 3, 5 and 7. This is how the state space tree is constructed for this sum of subset problem.